Okay, we're moving on to a brand new topic now. It's something that has come up occasionally in the course of our class, and I've mentioned it here and there, but we've never actually talked about it yet. It's the topic of complex numbers. Okay, so in this video, we're just going to introduce the basics of what complex numbers are and what they look like when they're simplified. We're going to talk a little bit about where they come from and how they're used. But really, we're going to just approach this mostly from sort of the academic theoretical kind of approach in this video. Uh, we will be on this topic for about 2 weeks or so. So there will be plenty more opportunities to see exactly how we use these. If this seems a little bit sort of out of left field in this video, just hang in there, be patient, and you'll see where this is leading soon. Okay, so with that said, let's take a look at our learning objectives for this video. So here they are, learning objectives for this video. You can see there's only 2 of them, but that first one has a boatload of information with it. And so really all of this information in the first learning objective is the basic knowledge that you're going to need as we look at complex numbers, as we talk about them, as we use them. This is just basically becoming familiar with what a complex number is and how it works. The second part is simplifying them, what they look like when they're simplified. And actually, these two things connect to one another because standard form, very similar to like it was when we talked about standard form for polynomials, we're going to want these things to be simplified when we're doing this. Okay, so those two things kind of connect together. But for the most part, what we're looking at with these learning objectives is a lot of vocabulary and learning to recognize things when we see them. I will have another video that has examples of how to simplify things, because with this much to talk about in this particular video, I'm afraid that this is just going to get a little bit long if we're not really careful. So with that said, let's get started. The first thing we have here is introducing something called the imaginary number or the imaginary unit. Different math books call it different things, but we're going to start with a definition of what the imaginary number is, or the imaginary unit. Okay, so a definition, an imaginary number. And I will use both the term number and unit, both. I'll use those words interchangeably. The imaginary number, the imaginary unit. You may have seen this in other algebra classes. It's represented with the letter I. Okay, so this definition is going to be a little unique because we're not going to write this definition as a math sentence. Or I'm sorry, as a sentence in English. We're going to write it as a math sentence. And if you remember back from elementary school, math sentences are equations. So this definition is going to be strange because it's going to take the form of 2 equations. So the first equation says that I is always equal to the square root of -1. Okay, that's the first half of our definition. I is just simply defined to be the answer when you take the square root of -1. Okay, now this is, where does this come from? Why does this work? Whatever. It's a definition. It's kind of like asking, why is a dog a dog? Well, somebody, when they saw a dog hundreds, thousands of years ago, they decided to call it a dog, and that just became what dog was. It's the same idea here. A few hundred years ago, mathematicians were working with stuff. They discovered that taking the square root of -1 is sometimes something that comes up that's necessary. Sometimes it's useful. And so they needed something to call that, and they just chose to call it I. So this is not something you have to understand where it comes from. It really is completely arbitrary. It just is simply a definition. But the definition has 2 parts. The first part is that I is always equal to the square root of -1. And the second part is very similar. In fact, a lot of people, when they see the second part, they kind of think that it's just the first part modified. And I suppose there's a sense in which it is. The second part is that I squared always equals -1. I squared always equals -1. Okay, so these are the 2 parts of our definition. And why it's necessary to have 2 parts is perhaps a little bit beyond the scope of our class. But you'll see as we start working with imaginary numbers that those 2 parts work together to tell us basically that you can and should use order of operations when you're working with complex numbers. However, some of the shortcuts that we've learned with real numbers will not work because of the 2 halves of this definition. But I'm getting way ahead of myself. That'll come in later videos later in the week. Okay, let's stick with this right here. So this is what the imaginary unit is. All right, so the imaginary number, the imaginary unit, whatever you want to call it, is I. That's what the imaginary unit is. And we define I as being the answer when you take the square root of -1. All right, so it's just really that simple. Okay, now I do want to talk for just a second about the terminology here, because this is, in my opinion, a very unfortunate terminology. We call these things imaginary numbers. And in English, imaginary has a certain connotation with it, right? Because when we talk about imaginary things, we talk about things that don't exist, right? We talk about, for example, that perhaps unicorns are imaginary, or leprechauns are imaginary, or these things that we have this concept of this creature or this entity or this thing, but we know that in real life, those things, you never run into them, you never see them, you never bump into them. Well, that's not the case with imaginary numbers. And so I do want to make sure that as we introduce this topic, that I stress the fact that this is not some arbitrary, it's not like we're studying unicorns here. Okay, imaginary numbers are an actual number that actually occurs in nature that different people bump into depending on the type of mathematics they're doing. For example, if you have an electrical circuit with alternating current, which is exactly what's in your house, alternating current is what's in your house. It's what you plug your computer into to watch this video, okay? The stuff that's coursing through the wires in your house, if you were to sit down, if you were an electrical engineer and you wanted to do a bunch of math with the circuits associated with alternating current, you would need to use imaginary numbers in that math, because there's this inherent property associated with electrical circuits that have alternating current that results in the generation of these imaginary numbers or complex numbers. So it's not that these things don't exist. They do exist, and they're very important in modern mathematics, okay? But we call them imaginary through an unfortunate series of happenstances. All right, so that's just a little aside. I'm getting on my soapbox a little bit because a lot of students complain, why do I need to learn about something that doesn't really exist? Okay, so we're not studying unicorns here. We are studying something that is real, it's out there, it's something that different people do bump into over the course of mathematics. And so it becomes important to study, just like some of the other things that we talk about in this class, right? Because a lot of the things we talk about in this class, you will only use in your future life if you have a job that uses that kind of mathematics, okay? And this is one of those things. There are some people who have jobs where they will use imaginary numbers because they are real and they are important, okay? It won't be all of us, but some of us will. All right, so with that said, let's get back to the main topic here. So we've talked about what the imaginary unit is, and this is the definition. The next thing we want to do is talk about complex numbers. Okay, so at the very beginning of the year, the very first lesson we talked about the different kinds of numbers. And in that video, I introduced very briefly complex numbers, but we didn't talk about them at all. Okay, so complex numbers are numbers that have a particular form. And what I'm going to do is I'm going to write it in what we call standard form. But of course, we know, because we've done enough math, that just because something has a standard form, that doesn't mean it's always in standard form when we first encounter it. Sometimes you have to simplify it. And that is going to be one of our learning objectives in this video. All right. So here is the form that they take. Okay. A plus BI. This is the form that they take, A plus BI. And so one of our learning objectives is to know what a complex number, to recognize it when you see it, and to know its parts. And so that's what we're going to talk about here. This is the form that complex numbers take. And you can see that there's basically two parts here. There's the A part and there's the B part, and they're separated by a plus sign. Okay. Now, just like it was when we studied the quadratic formula and things like that, A and B are simply numbers like we're used to. They're real numbers. It could be a 5, it could be a 0, it could be a 10, it could be a 3.9, it could be a 7.5, it could be a -12, whatever. They're just real numbers, okay? So these two things are going to be real numbers. And then there's I. In I, we've defined, I is the imaginary number. It's the answer when you take the square root of -1. So this I right here is the same as having a square root of -1. Okay, that's what this represents, all right? And so this is the form of the structure that things will look like. So it could be like 2 plus 3i. That's an example. It could be a -5 plus 12.3i. Okay. It could be 17 plus a negative, which would be like minus pi I. Okay. That would be weird, but that would be totally acceptable. Okay. So these are like some examples of what they look like. All right. So you see, every one of those things has two parts to it. The first part is the part where there's not an I. We call that A. So in this first thing, we would say A is equal to 2. And the next thing we would say A is equal to -5, so on and so forth. This is called the real part. Okay. The real part, the part that doesn't have the imaginary number, is called the real part. And then there's the second part where the B is, okay? And the B is always partnered with an I. So here we would say B is equal to 3, and then there's an I. Here, B is equal to 12.3, and then there's an I. Here, B is -pi. Just like polynomials, the negative sign goes with the number. So we would say B is equal to -pi, okay? This is called the imaginary part. That's the imaginary part. Okay, so every complex number has a real part. Every complex number has an imaginary part. All right. Now, what happens is you can have these things called real numbers and purely imaginary numbers. So you can see these are our next two learning objectives, real numbers and purely imaginary numbers, by taking a complex number and having one part equal to 0. So for example, I would have real numbers anytime B is equal to 0. Because think about what would happen here. I would have, let's say I've got 3 plus 0i. Well, 0 times anything is equal to 0. So this would be the same as 3 plus 0. And of course, 3 plus 0 just equals 3. So notice here's my complex number, but it simplifies just to be a regular old number like we're used to. So if I had, any real number that you've used all year long, 3/4, plus if B is equal to 0, I'd have 0i. 0 times I is 0, so it's just 3/4 plus 0, so I get 3/4. So any number that we've used all year long, if you tack a plus 0i at the end, then basically what you're doing is you're making that thing into a complex number. So real numbers are just complex numbers where the B part is equal to 0. Okay, and then we have things where the imaginary part does exist, but the real part doesn't. Those are called purely imaginary numbers. Purely imaginary numbers, anytime the real part is equal to 0. So again, if I had a 0 plus, I don't know, 2i, well, 0 plus anything is just itself. So it just becomes an imaginary thing with no real part to it, okay? So 5i, if it had a real part of 0, just simplifies to be 5i. All right, so what we have is numbers that look like this are called purely imaginary numbers, okay? And a lot of times we just simply call them imaginary numbers, okay? Just imaginary numbers is good enough. Numbers that don't have an imaginary part to them, these we call real numbers, all right? And then if it has both parts, those are called complex numbers. Now, here's the thing, unfortunately, is sometimes math people get a little bit lazy. And sometimes we take something that's actually complex and we call it imaginary. So that can make these things a little confusing, which is why over the years, some mathematicians have started calling these purely imaginary, because then they can call this imaginary and you can tell the difference. Okay, technically, this is imaginary, this is complex. But that's something that we'll be a little forgiving with in our class because mathematicians in the wild are a little forgiving, all right? Well, those wild mathematicians. All right, so here we go. We've taken care of basically our entire first learning objective. We've defined the imaginary unit. We've talked about what a complex number looks like. And so therefore, we've also talked about standard form. We really have covered both of these things, right? Standard form is A plus BI. That's what standard form is, okay? We've talked about real number is what you end up with if B is equal to 0, and imaginary numbers are what you end up with when A is equal to 0. All right, so that really takes care of the whole first learning objective. All right, our second learning objective then is how to simplify a purely imaginary number. So I'm just going to mention very, very quickly in this video the idea. But like I said, there's going to be a second video with examples that you might want to watch. So simplifying imaginary numbers. Okay, so this is a number where there is no real part, where the a is equal to 0. There's no real part, okay? Now, here's the thing, is if you have to simplify it, you might not recognize that it's imaginary. What you'll see instead is the square root of a negative number. This is what you'll see. So when I see this, this is considered not simplified because there's a symbol that represents the answer to this. So when you see a square root of a negative number, so square root, I hope you can take that abbreviation for square root of negative numbers, square root, I'm struggling here, of negative numbers are not simplified. Okay, that's just, we just take that as a rule in math. If there's a square root of negative number, that's not simplified. So what you need to do to simplify it is you need to bring in the imaginary units. I's are simplified, generally speaking. Okay, we'll see when we start doing exponents that you have to be a little bit careful. But generally speaking, we call I simplified. So the whole idea of simplifying imaginary numbers is to break out this negative sign and turn it into an I. Right? So here's a basic example, and then we're going to wrap up this video here. Suppose I have the square root of negative 3. The basic idea is you want to think of that as not being just simply a negative 3, but as being 3 times negative 1. 3 times negative 1. Maybe the better way to write it would be with parentheses. So if you do that, then you know from when we studied radicals that you can distribute the radical. And so now you have something that's like a normal, regular, real number, square root of 3, and you have something that becomes imaginary. So we'd have the square root of 3 times I. And so this is the idea for simplifying. Now it does get more complicated, and in the next video, I'll also write down a basic procedure that you can follow, but this is the general idea. All right, so I'm going to wrap up this video here. Like I said, I'll have another video where we detail this in more detail with a procedure and more examples, but that's the idea of simplifying. And that also covers the basic familiarity that you need to have with these different terms and definitions. All right, so thanks for watching. Have a good one.